G'day. Let's be honest, teaching coding can be a bit scary. After 25 years in the classroom, I've seen it. No time, fear of change, and tech that looks more like trouble than teaching. But Scratch 3 is different. No weird code, no error messages, just drag, drop, and make stuff. If you can dream it, you can build it. Let's take a simple problem, plan a solution, and test as we go. Tiny bugs are easier to squash than sorting through a wall of blocks. Let's dive in, and yes, dad jokes may happen. You've been warned. Alrighty, let's take a look at how we could tackle part B of the Digital Technologies unit, the amazing digital design. We'll start by heading straight to the marking guide so we know exactly what's expected. In here, it outlines a few key things. First, students need to identify a problem. Then they must incorporate decision making, repetition, and a user interface in their solution. There's also a focus on communication and collaboration using agreed protocols. Now here's something important. A lot of people treat the programming as the main event, but really it's the process leading up to the product that matters the most. In fact, the game doesn't even need to work. It just needs to be well designed. If students can show strong thinking in their design, they can do well in the assessment. So how does this match up with the design process? Step 1 is defining the problem. What are we trying to solve and what are the constraints? Well, the problem is we need to design a game. The constraints: it must use visual programming like Scratch. It must include decision making, repetition, a user interface, and be developed collaboratively using protocols that are agreed upon. Plus, it needs to be edutainment, a fun maze-style game that teaches a concept from another subject area. So not just fun, but educational too. It may also involve things like scores, time limits, or indicators of how well a player is going. And of course, the player needs to understand how to actually play the game. Once that's defined, it's time for research. What kind of games are already out there? What makes a game fun? Why do we track scores? What shows a player they're doing well? After that, students brainstorm ideas, and here's my tip. Don't settle for just one. Aim for at least 3 possible game ideas. That way, students can justify their final choice and reflect on why it's the strongest choice. It also gives them more to talk about when explaining their ideas in their assessment. From here, it's time to plan and create the game using Scratch. But we're not done once the game is built. A key part of this process is reviewing and improving. Students should seek feedback from peers, make improvements, and possibly revise their original plans. This cycle of testing and tweaking is essential. So those are the big ideas to keep in mind as we begin this unit. Next up, we'll jump into Scratch and look at how we can start bringing these designs to life.